So now we are going to be combining what we've been looking at, molecular formulas, empirical formulas, and we're going to be able to find the molecular formula if we are given the empirical formula. In order to do this, we have to be given the molecular mass. All right, let's look at our empirical formula in this problem. It is C3H7. So what I need to do is find out how many empirical formulas will fit into my molecular mass. And so what I'm going to do is add up my carbons and my hydrogens in my empirical formula. So I have 3 times 12, 36, and I have 7 times 1 is 7. So that gives me 43 grams. So how many 43 grams can I put into 86.2 grams? So you're going to put the molecular formula mass on the top, and you're going to put the empirical formula mass on the bottom. So I end up having 86.2 divided by 43. And when you divide through, you get a whole number. You will always get a whole number. If you don't get a whole number, you have goofed. So I get a 2. So this is not my answer. What this is telling me is that I have 2 empirical formulas. So kind of 2 ways to look at it. I could add them up, or I can multiply through by 2. Either way, you're going to get the same answer. So this is our molecular formula. So again, I can see that there's 2 empirical formulas there because if I divide by 2, I get that empirical formula. All right, here's your step-by-step rules. So you need the molecular mass and the empirical formula. They will either be given to you or you might have to find the empirical formula using percent composition data. So find the empirical formula if you need to, then find the empirical formula mass, find out how many empirical masses are needed to get the molecular mass, and so you'll divide with the large number on top. You will always get a whole number. You will multiply this number through by the empirical formula. Let's do one more example. A molecule has the empirical formula of HO. Its molecular mass is 34 grams. Find the molecular formula. So I know that this is my molecular mass. That's going to be my large number. And I'm going to divide it by the empirical formula mass. So that is 1 plus 16. That is 17. And so I get 2. So I'll take this and I will multiply it through by my empirical formula, and I get H2O2. You do have to distribute it out. This is your answer, hydrogen peroxide, H2O2. So the empirical formula is a 1-to-1 ratio, and I find by being given the molecular mass, I have 2 of those empirical formulas. Let's look at an example that pulls it all together. We're given percent composition data, and then we need to write the empirical formula, and then we need to write the molecular mass. All right, so again, if there's percentages, cross those out and put grams. And I just have 2 elements here. So I have 92.3 grams of carbon. I'm going to divide it by 12 grams of carbon because I look on the periodic table, and 12 grams is equal to 1 mole. And I get 7.69 moles of my carbon. Then my hydrogen, 7.75 grams of hydrogen divided by 1 gram of hydrogen. This is the only time 1 mole equals 1 gram. And I get the same number. I'm going to divide through by the smallest number, which is 7.75. And I'm given a 1. This one up here is 0.99, and that is pretty close to 1. So this is an empirical formula of CH, a 1-to-1 ratio. So how many of these CHs can I fit into this 78? So 78 goes on top, and on the bottom I will add up my 1 carbon and my 1 hydrogen, and I get 13. How many 13s go into 7, or excuse me, how many 13s go into 78, or 78 divided by 13, I get 6. So my molecular formula is C6H6.